Okay, good morning. Welcome to
KidMath128.
KidMath128. Do you know anything special about the number 128?
It's a power of 2.
It's a power of 2. Yeah. That is 2 to the, let's see, 7th. But anyway, so that's kind of fun. Today we're going to talk about a new function that you're going to learn about much later on called sin x. And sin x is a function that relates to circles. And the reason I wanted to talk about this today is because it's
Pi day.
Pi day. But we're not talking about circles and trigonometry right now. We're talking about what?
Polynomials.
Polynomials. Well, it turns out this function sin x, which looks like a wave in the ocean, and I've graphed it from 0 to 6.29 because it has zeros at 0, pi, and 2 pi. What's 2 pi approximately?
It's 6.28.
Yeah, that's 6.28. I'm going to show you how this function can be approximated by polynomials. The first polynomial we're going to look at is x minus x cubed over 6. And the graph of x minus x cubed over 6 looks like this, which really doesn't look at all like this, from 0 to 6.28. But when I regraph them together from 0 to 2, which is this bottom graph, you can see they do look pretty close together. Okay, so now I'm going to add another term to this polynomial, plus x to the 5th divided by 5 factorial. And 5 factorial, do you know what 5 factorial is?
5 times 4, it's 120.
120, yeah. So here's the new functions again. X minus x cubed over 6 plus x to the 5th divided by 120. That looks like this, which looks really nothing like this.
Yeah, but it looks like over here they're similar.
Except from 0 to 2, it really looks similar. Okay, the next term in the approximation is minus x to the 7th divided by 7 factorial. And again, you can see the top function really doesn't look too much like that at all from 0 to 6.28.
They're almost exact.
Now from 0 to 2, they look so similar that maybe I should expand it to go from 0 to 3. Okay, and even from 0 to 3, you can barely see that they're diverging, right?
Yeah.
Maybe I'll go from 0 to 4. Okay, finally we can see that they're a little bit different from 0 to 4, but from 0 to 6 they look nothing alike.
Yeah.
Right? Now just for fun I'll just add in a couple more terms. Plus x to the 9th divided by 9 factorial minus x to the 11th divided by 11 factorial. And now from 0 to 4, you can't even tell the difference, right? And from 0 to 6, well, still not quite right. But maybe one more term will get us there. Plus x to the 13th. Okay, we'll stop here anyway. Oh, actually, they do start looking...
This one has roots not... It looks around more like 6 than 6.2.
Yeah, it looks more like 6 and 6.2, but at least this function is starting to look like that.
Yeah.
And you can see how the approximation gets better and better and better. So this is some stuff from some advanced math. You learn about this in trigonometry. That's where you learn about the sine function. And you learn about these approximations, which are called Taylor series.
Cool.
In calculus. And you learn how to do this. It's pretty neat, right?
Yeah. So
there you go. So for Pi Day, here's how we can approximate some functions relating to pi with just plain old polynomials. All right, good job this morning, huh?